All right. So for today, we're gonna focus on this PowerPoint. Mainly, it's about strings and text files. And just like before, we're gonna focus first on all the important points. We're gonna try and finish the two PowerPoints first, and then we'll come back to the other slides that were not discussed later on, because those things can just be self-studied on your own. Okay? So we're gonna focus on the main points first, because again, if we discuss everything um, per slide, it will take a lot longer than 4 hours. So we're gonna maximize the use of our time and focus on the important parts. All right. So we'll be observing more carefully how strings work, their structure, and mainly the thing called substrings. We'll be exploring that one as well. All right, now this is what a string would look like. Now, a string is actually a data structure. Now, when you say a data structure, it just consists of smaller pieces of data, or in another word, it's just a collection of data. All right, it doesn't necessarily mean that it has to be smaller pieces of data, because as you later learn, you can have a data structure that has large pieces of data attached to it. All right. Now, let's focus on that concept first. It contains smaller pieces of data. Now, as a string, right, what data does it have that's considered smaller pieces of data? So it's actually characters, right? That's the reason why it's called a string, because it is a series of characters. It is a string of characters. And because it is a string, it has to follow a certain order, all right? So it is an ordered data structure. It follows a certain sequence, all right? Now, we have a special function here, the len function. It returns the string's length, but this is not the limit of the len function. You can try using the len function on any kind of object in Python, and it will almost always give a an answer. So it can either be one or two, or depending on if it's a data structure, it can be a lot bigger than that one. All right. So basically, um, it counts how many of those smaller pieces of data are inside of your data structure. All right. Um, if it's just one item, then it will just give out one. All right. In fact, if we try it out here, if we try len of a certain number, let's see, int has no len. So we can say that int, therefore, is not considered a data structure because the number itself is what we call a primitive data structure. So it's the um, smallest, how do I say this? It's the most basic data that you can get. There's nothing smaller than that. So we call it a primitive. But if we use a string, let's say, for example, my name, right? It will count each one and we'll try to check if there are primitive parts or smaller items of data, right? In that data structure. And it has, and that is each character in a smaller piece of data. So that means it will count each one and it will give out 6. All right. The same with the example here. Hi there. So it's 9 because it's counting the space. The space is a character and also the exclamation point. All right. If you say len of a blank, it will give out 0. Okay. Now, what's this picture that you see below? Now, this is the inner structure of a string. Now, from left to right of any string, it will always assign the number 0 at the very beginning. And then as it goes to the right, that number will increase by 1. So 1, 2, 3, and it gets assigned to each character in that certain um, point. So at the punctuation point, it's 8. Now, what I want you to observe is if you actually count this one, right? It's kind of confusing at first. It's numbered 0 to 8. But if you count this one, there are actually 9 numbers, all right? And that 9 numbers is actually our len here, okay? So don't be mistaken that the len is automatically the index number, all right? But we do know that the maximum number 8 is just len minus 1. That will always be true. So the maximum number, the last index number for any string will always be len, the count of how many characters, minus 1. So that's it. See? So this is how it works, all right? Every character from left to right will get assigned a number called an index number, and then it will increase by 1 from left to right. Okay, it will include all the characters, even the space and the special characters. All right, so it's that simple. Let's see. If we try out, let's say some weird characters, for example, mixed with numbers, and then some other, maybe not open and close parentheses, just to be sure. Something like that. And as you can see, it will count everything there. So this makes it a lot easier for us to check later on instead of actually counting one by one, right? Which gets confusing very easily, right? Because you have to do it one by one, 1, 2, 3, 4. And that's very error prone, right? We, let's, we should make use of what our devices can do. So let's go to the next one. Now we go to the subscript operator. Now, how does a subscript operator work? What is the syntax? So this is the syntax of a subscript operator. You start with a string, followed by an open and close bracket, and then inside there is an integer expression. So take note, it must be an integer, and it must be an expression, or it can just be a solo integer number, okay? And here are some examples of what it's doing. So if you want to access the first character. So we know that that is for index 0, right? So we can get the letter A. If you get index 3, you get letter N. If you get the len, for example, this will give you an error. Why? Because you are going over the maximum index that the data structure can give. So that's what will give you an error. So it will say oops and index error, trace back, and then it will give you the line of where the error occurs. And of course, the error message index, error string index out of range. If you say len of the name or the variable minus 1, you will automatically get the last index number for that string. And that's what we get here, G. Okay. You can also use negative index numbers if you want. And this will, you can just try counting backwards. So if 0 is over here, right? -1 is over here. -1, -2, 3. Because sometimes it's easier to count with negatives. Not always, but sometimes. All right. So if we go back to our example here, and then um, let's make something. Let's see what's a little practical. Maybe first one. Okay. All right. Okay. So let's say, for example, in your data set, this is what it looks like, right? Let's say your data set came from surveys of around 10,000 people, for example. And then one of those surveys, you have this data in there, and you only want to extract the name. Okay. So, um, how would we extract that one, right? So we would actually extract these numbers one by one. So first, we gotta know where it starts. So it should start after the space, right? It should start after the space. So if we just try out like, uh, let's see, let's assign this string to a variable first. Okay, all right. And let's just try things out. Not really counting things. So if we try out temp of 10, what do we get? Oh, okay. So we get the columns. If we go 11, that will be the space, right? So that means all we have to do is get each one, right? After 11. So it's 12, 13, 14, 15, 16, and 7, right? Because there are 6 characters in that name. So if you actually put a print, 14, 15, 16, 7. All right. Now, if you're looking at the output, we actually got each character from the name, all right? Now, you might be thinking it's very tasking to actually do it in this manner. So there's actually a different way to get a certain range of um a certain range of characters within a string, and that's actually what we call a substring. All right. And that's what we will discuss next. So if you go here, this is just using a for loop. So basically, yeah, all right. Before going to the substring, let's do this first. Um, it's actually quite simple. They're using a for loop here to actually check each character in the string. So as you can see, for index in a range of len data. So len of data is high there, right? It will give you the maximum uh, index number. Okay. So we don't actually need to do a -1 here because the range function, if you remember, if there's just one argument, then that will be the stop parameter automatically. So it's not going to include that number, right? So if there's 9 there, then it will only output 0 to 8, which is actually correct. It corresponds directly to the index numbers for this string. So this is actually a sort of hack, really, for accessing quickly each character in a string. And all you have to do is just print out the index and then data of that index, and then you will have this kind of output. So 0, H1, I, 2 space, and so on and so forth. Okay? So it's just showing you that you can use loops to also access each character in a string and then show each character. And now for the substring. Now this is how you actually select multiple characters or a range of characters in a string, or more specifically, a substring. All right. So the actual name of this one is called slicing, and we're going to be using the colon operator in order to indicate that range. So, for example, you have here my name. So let's say that this program was actually collecting all the file names, and you just want to isolate the extensions or the ones after the dot. So if you want to do that, you can start at 0 up until to the end. It will get the entire string. If you say 0 to 1, then it will start at 0 and stops at 1, not including 1. See? 0, 1, stops at 1, but it's not including the y. If you say 2, okay, it's going to stop at index 2, and it's going to include m and y. All right? Um, Next is it's using the len. So as you can see, there's no number before the colon. And that means it will just start at the very beginning. If there's no number after the semicolon, oh no, wait, after the colon, then you're just telling Python to get everything up until to the end of the string, right? So what does this mean? So at the very beginning, so M, and then up until to the end, or len of name, which is not included, it will still get the entire string, right? If you start with a negative index number, all right, and then a colon. So what does it do? Um, Again, even though it's negative, it's just a starting point. It doesn't really tell Python to count from right to left. It will always count from left to right. So as you can see, negative 3, so negative 1, negative 2, negative 3, and then followed by colon, so up until to the end, so negative 3, up until to the end, that's why you can see txt here. And then finally, uh, on the last part here, if you just want to get the file name, then let's see, uh, or actually the word file in this case, is extracting the index 2 up until 6, but not including 6. So let's try and use this one. So let's say in our data set here, we only want to get the name. So we know that the name will always start after a colon. We also know that the colon starts at index 10. So why don't we do that one? So instead of doing it like this, we can do it like this. So print temp, temp, and then and up until to the end, and then that's it. If I run this code, it will print out the email. So this is still wrong. It's including the colon operator. So we should start at 11. There you go. So you can include this one, this simple code in your in the part where you're cleaning up your data set. And when you have it, right? You're cleaning up your data set, you're trying to get the data that you need. So yeah, you can include this one when you have the string itself, and then just extract the name only. So yeah. All right. So testing for a subscript with the in operator. So technically you just want to check if a certain string or substring is in another string. You want to check if the name or in this case the extension txt is in one of those file names. Or you want to check if one of those, let's see, one of your data sets here. So we have first names, right? Let's say we have, let's see, strings. Let's say one of their data is for the address, right? And then you're just looking for example, uh, we have a bunch of addresses here. Like, I think of something. Let's see. Maybe this one, or okay, maybe this one. Boracay, for example, and then a country, right? So what if you're just searching for a specific string, namely the country, right? So you can test that out by looking for that exact string only. And the way to do that is using the in operator, all right? Not necessarily an if. You can use this one in for loop as well, but the in operator is basically a Boolean operator, so it will output either a true or false. Okay, so we have an array here. So each array, the array is also considered a data structure. So what are the smaller pieces of data set? These are the smaller pieces of data set. So it's actually a string, which also has smaller pieces of data set, right? You can think of it like that. So um, if you put a list in a for loop like this one, so for file name in file list, I think we discussed this one before. So the array will give out each item to the file name here. And now at that point, at that iteration, we have momentary access to that um, item or that data. So we're trying to check here if text.name, if text in file name, we're trying to check if the file name has the .txt, then it will print out the file name itself. So basically the output, this is the output here. You will only see my file.txt and your file.txt. So in this case, if we have a bunch of addresses here, let's see. Let's see what that means. Hmm, and then what's the other one? Hmm, all right. So let's say you're looking for a specific country, namely this one, for example. So you're gonna loop over, right? You're gonna loop over. Um, let's see what variable will give it. For each add in addresses, right? What's this? Ah, okay, grammar. Um, then you will have access to each one, right? If you just print this one out, you will get each one, right? So if we add a condition here that will check if, oh no, wait, yeah. So if we can print out got one, for example, else, um, we can print out skip. Oh, okay. So as you can see, this is the result. So for add in address, we have access to each address, right? And then if the Philippines, the word Philippines is inside of there, then um, it will print dot one. Otherwise, it will print out skip. So this is correct. This should be dot one, and this should be skip and skip. So there is a problem with this program. Can anyone see a problem with this program? Any volunteers? Let's go with Neil. You see a problem with this program?
So, sir, pinaprocess ko pa
Ah,
po.
okay, okay. How about the others, Paolo and Anthony? We seem to have lost the other two. I hope we'll be back. Uh, Paolo, Anthony, are you guys here?
Sir,
You have
tama ba yung kumbaga kapag Philippines, hindi na kailangan ilagay yung sa Boracay?
yeah, there's no need to put it in anymore because you're just looking for if this address has this specific text in it.
Hmm, okay. Okay.
Okay. So can
And,
anyone
I think, sir, kumbaga nag-appear parehas yung got one and skip dun sa result.
oh no, that's perfectly fine because that's how we did it. I mean, like, can you see a problem with this program? Like a potential problem in the future.
Hmm. No idea, sir.
Okay, that's all
No.
right. How about the others? Anthony or Neil, were you about to say something earlier?
I-ano ko sana sa sir yung sa buwang sa Grammarly lang ata yung add-in. Pero, wala na. Wala
Ah,
pa po.
yeah, this is from Grammarly. Sorry, I don't know how to um remove this one. Maybe I can disable it here. So no, I don't know. All right, so actually, there is one thing that we can see an error here is that if the capitalization is different. So let's try a small p, shall we? And let's try it out. So as you can see, even though Philippines here is present, it will not detect it properly just because of the small letter p. So remember in these kinds of conditions, it needs to be exact. They need to be exact. So one way to do that is either you convert your string here, all your strings to lowercase, and then the one that you're comparing is also in lowercase to make sure that they match. Or it can be the opposite. You can convert everything to uppercase, whichever one you prefer. And then go back to capitalization afterwards. Um, or you can just temporarily, because you're not editing the value here, you can temporarily make it into lowercase and then compare it here to check if it's actually like the same. And then it will not affect the original address in any way. So if I remember, there was a string method Python. Let's do a quick search. I don't have this one in my head. Let's see. Yes, we have this one. It's called lower. So it doesn't need any arguments, just the function call. So we know that add here will be automatically a string. So we can just anticipate that one and then say lower. All right. So we automatically add a method. We haven't discussed, have we discussed methods before? Let's see. If we have examples of that one, then we most likely have discussed methods. Mm, I don't know what's wrong with now. Let's see. Right. So I haven't really gone through that one before. And that's okay because that's part of our lesson for today. So um you could use methods or you could use other functions or something in between to process changing this one to lowercase. But this is the most easiest one using a method. Now, method or functions, they're technically the same. The only difference is that methods work only on the object that it is called on. So add that lower, the lower here will work only for the add object. All right. Now, if we run this code again, we got the correct answer again, right? Okay. Apologies for the pause. So yeah, more on methods later. Just remember this one that there are ways that there are functions that will only work on a certain object or where they're called upon. So we'll discuss more on that later. All right. Next is actually let's do some exercises first. Just simple exercises. All right. So let's see. I have one prepared here. Okay. Mm, all right. So a vowel counter. I want you guys to create a program that counts the number of vowels regardless of the case, all right, in a user entered string. So you're gonna have to ask the user for a string, and then I want you guys to use a for loop and the in operator, this one, to iterate through the string and then count the vowels. Okay, so if I have like, for example, uh, my name, right? So how many vowels is that? That's one, two, or three. So your output should be three. Okay, so a vowel count. So I guess it's 5 to 10 minutes for this one. That should be enough. All right. So your timer starts now. All right, it's been 10 minutes. Does anyone have an answer? Hi, Catherine. Nice of you to join us again.
Yeah, I lost my data.
That's okay. So, Anthony, Paolo, Neil, does anyone have an answer?
Yes, sir. Can I show my answer?
Mm, Oh, oh. All right, you have the floor, Anthony. Wait. All right, we can see your screen. Can you explain to us your solution? I think you're muted, sir.
Hello? Can I be heard?
Yes.
Yeah, so actually I created two solutions. One in which we will manually convert to uppercase or lowercase the vowels, and then the other one will be using the lower function. So the first one is the manual. So I started by inserting by assigning the input into a variable user string, and then vowels will be equal to lowercase a, e, I, o, u, and then uppercase a, e, I, o, u, and then the vowel count will be initiated to 0. And then for the for loop, for car in user string, if car in vowels, then vowel underscore count equal to vowel underscore count plus 1. So that means that it will be evaluating each character in the user inputted string, and then whenever it finds one, automatically it will uh, it will count, and then the last count will be what I mean is it will add another one to the last count whenever it finds a vowel. And then it will already print yung number of vowels in the string. And then dun sa second solution ko, I just made use of the function lower, so that whatever even if the user inputs an uppercase character, uh, it will automatically be transformed into lowercase. That will be all. Thank you.
All right. Thank you for sharing your solution, Anthony. So it's both of them are actually correct. The one is using methods, the other one is using the lowercase and uppercase vowels at the very beginning. So either one of those is actually correct. Shares. All right. Does anyone have a question with Anthony's solution?
Sir, question lang po in regards sa medyo similar lang din man po kami ni Anthony ng solution.
Solution.
Pero may question lang ko if ever pwede pong kasi ginawa ko pwede po bang share screen?
Okay. Stop share. All right.
Teka lang, bro. Teka lang, teka lang. Sir, ang ginawa ko kasi dito sa... Kita niyo na po ba yung screen?
Yes.
Okay. Dito po sa vowels, at dito sa may ah yung that lower at upper.
Mm.
May mas magandang paraan po ba para parang isang function na lang itong dalawa? Kasi ginawa ko kanina, tinry ko kaninang that upper is medyo newbie question lang po. Parang mali, hindi po nare-recognize naman yung lower if ginawa ko yun. Kaya ang ginawa ko na lang po is pinagdalawa ko po para ma-identify po na ah, ma-identify both yung lower and upper case. Kasi pag inano ko po siya ng normal lang, yung pagtanggalin ko po to, out. Teka. Ah, ang na-identify niyo lang po is yung parang may mali po ba? Parang may mali yatang ginawa. Tama. Yung dalawang lower lang po yung nakikita, nababasa. Kaya dinagdagan ko po nung code na ay inisip ko po nalagyan nung kanina, sorry.
All
Kaya
right.
dinagdagan ko ng
So,
uppercase.
mm,
Kaso, may mas magandang paraan po ba na hindi po ginagamit to para mas malinis tingnan. Para hindi po yung double lower, may upper. Kung may function na po na isa lang. Para both cases, uppercase or lowercase, is ma-identify po if pag in-input yung string.
mm,
Medyo malinaw po ba yung tanong? Sorry po, malabo yung ano ko.
yes, it's okay. I understand the question. So if you're asking if there's a different function that combines the two, so I don't think there is. Right now your solution is also correct. It's just using one extra layer of um, condition and also another method. So in terms of efficiency, your solution is less efficient, but it's still correct. So your problem was that it cannot detect the uppercase, right?
If
So that's
ginamit ko yung
why,
lower.
yeah, so that's why I suggested earlier, either you can shift the original text to lowercase so that everything
Okay.
is in lowercase or in uppercase, either one. Or if you want, you can have it like what Sir Anthony did. He combined it in the comparison string, both the uppercase and the lowercase vowels in that string, so that you don't have to do any kind of um, function call or any methods anymore because it's in the string, both the capital and the lowercase vowels. So it's a bit more efficient because there are just a few vowels. If you're using consonants, then it might be a bit more inefficient because there's a lot.
Yes.
Yeah. So yeah, I hope that satisfies your
Yes. Uh, so
question.
far, if consonants po yung gagamitin, mas efficient po na i-convert po yung string to either uppercase po lahat or lowercase, then saka po i-identify. Is
Yes,
that correct? Okay.
that's more efficient and easier to understand.
Okay, thank you po. Sir. Yan ako na po. And can we share? Thank you. Wait, how do we
Welcome.
stop sharing? Okay, thank you.
Okay. All right. So that's it for our exercise. So just one for now. Uh Actually I have another exercise, but it's kind of not really an exercise because it's just a kind of trick in Python. So there's actually a way to if ever you were asked to reverse a string, there's never really a lot of applications on this. I don't really encounter a lot of cases where you need to reverse a string. But in the case that you do need to reverse it, you would only need to use two colons and negative one. So for example, I have this one here, right? I'll just remove these three. Actually, I have this create a new one. So I have temp here, my name. So all you have to do is two colons and then negative one. Okay. So it's not really like um it's not really like it's something that you have to remember because there are other ways of doing this. This is just a kind of like a trick, like a shortcut. If ever you were asked to reverse a string, you can do this one, colon, colon, and a negative one. There are methods that can reverse a string, I think. I think it's here. Let's see. Reverse, reverse. Where is it? Is it here? Upper, translate. um, Oh, there's a how to here. So, yeah, as you can see, there's one, and then let's see. Is it indicated? I remember there's a method for this one or a function. I'll just put it here when I remember it. But this is the kind of like a shortcut for that. So colon, colon, and then negative one. Again, I don't really encounter a lot of cases where you need to do this one. The only thing that I can think of is that if the string is too long and there's actually like um if you're counting your strings from left to right, like doing a for loop. So if your string is too long, then you're going over the strings you don't need, right? Let's say, for example, your string is blah, 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 for example, and then two dashes, and then this is what you need, right? You could just do a negative, or you can reverse it and do the usual one, right? Um, if you do a reverse on the string, you're kind of like I don't know which one is more efficient, either reversing it and then doing it by normal or using the negative substring operator and then getting the data that you need. So either of these two is can be considered correct. Yes, Anthony? I thought you have a
Hindi ko
question.
ata na-unmute kanina po. Sorry po.
Okay.
That's all.
It's all right. All right. So that's it for substring operator. Data encryption. I think we can go back to this one. For now, does it really involve data science? In a way, yes. This actually involves data science a bit. So let's just go over this one. All right. So a quick background. We are actually connected to the network hackers, which will use a sniffing software. So basically, they take a peek at your data. So that's why you don't connect automatically to public networks like malls or those ones that are free. All right, be careful for connecting those things. It's much better to use data. And then in order to protect our data, there are some encryption. All right. But again, if you're connected to those wireless networks that are unsecured, then there's really no use for encryption because they can see everything that you're doing already. So it's no use. All right. But for those secured networks, we have encryptions. All right. So even though if someone is taking a look at your data, they would have a harder time to actually decrypt it. Right. So those two words are here, encrypt and decrypt. So when you encrypt them, you are transforming your message into something else. that will be harder to read. So that's the ciphertext, all right? And then you have to decrypt it to be converted to the original plain text form. Now you would need keys for that one in order for it to work, all right? Now, this is the Caesar cipher. It's a very old way of encryption. This was very useful in the past, but nowadays it's not. So the way that this works is something like this. For example, the invaders, right? The word is invaders. So what they do is, for example, the key is 3. So what they do with that number is that you have to move the letter I 3 characters to the left. So that's JKL. That's why we have L for. Then NOPQ. That's why we have Q. And so on and so forth. So this is now the encryption, the encrypted text. All right. So what do you need again? You need two things. One, you need the key or how much you move each character. And then you need the original encrypted text as well. So what they do in the past is they send the message by 2 ways. So one is in a different direction, one is in another direction. So that the two can never be in one place, right? So it's more difficult to actually decipher the code. Um, but when it's combined again at the end, they will know that this was actually the message if they decrypt it back. So just like how we encrypted it, it's also the same way on how they decrypt it. So just move the letters back to how many keys it was encrypted, right? Okay, so how do we convert this one into um, the modern computer, right? Modern devices. So all the characters that we know, right, in every language in the world has a certain number to it, right? And that's what we have here. This is the ASCII values. Now the ASCII is just for um it's just one part of the information that's for uh basically the English language, right? It's under it's a subset of Unicode. So Unicode is the whole thing, right? It's all the languages, all their equivalent numbers that are assigned to each character. Okay, there is each one. So that is how information is actually transferred over the internet, over Unicode. So each character is expressed in a different code depending on what language you're in. So that's why even though someone is from Japan, for example, our computer can still see what character they are using if we translate it using Unicode. All right. So um like if you don't know what character they're using, but if you use Unicode as a way to check, right, it will automatically show you what character they are using. But in this case, generally everyone is using just ASCII, right? Because English is the universal language so far. So we'll just be sticking to this one. Now, if you search the ASCII values, I think we have this one here. So this is a table for the ASCII. All right, so these are the equivalent things, decimal, alt, hex, bin, and the HTML number. Okay, no need for that one. What we are interested in is the characters themselves. So if you go down here, this is for the symbol, right? What it's trying to represent. So we'll go to the letters, for example. So for the capital A, it's what's this? It's the number 65. This is octal, so we'll focus on decimal for now. All right. So as you can see for decimal, letter A is 97, the small letter A. So that's why what we see here is 97, and so on and so forth. B is 98, 99, C, 98, 99. So that's how it works, right? So basically, you might be asking, why do we need to convert it to numbers? Because the computer don't really understand letters, right? They don't understand letters like we do. We can't tell the computer to move 3 characters to the right of letter A because it doesn't know what letter A is, but it does know what zeros and ones are. So we can represent it in that way. And in order to make it easier for us, we represent that one into decimal. So as you can see, here is the equivalent in binary. See? So this is what the computer understands. This is what we understand, on the other hands. So um, if we say move 3 characters, we're just basically adding a 3, so 97. So 1, 2, 3, that's 100. So basically um, we're telling the computer to add the number 3 to this number to get this one, right? That's what we're trying to tell. In that way, the computer can now function like a Caesar cipher mill because now we can translate each character into their equivalent numbers. So the trick here is you have the encrypted text, convert it first into ASCII. You do the process, add, for example, 3 to each character. Now you have the converted value, the converted ASCII values. Next is you convert it back to actual letters or code. And that's how you get the encrypted text. All right. And the same thing can also happen for decryption. So encryption, decryption, it's the same thing. It's just opposite directions. So for decryption, you have to do it in a different way, in the opposite way. So you get the encrypted text, you convert it each one into ASCII, and then you deduct 3 to each character. Now you have the converted ASCII values. Then you convert it back to letters and numbers. Then you get the decrypted message. It's the same thing. And that logic is actually what's happening to the code that you see here on the following sections. So, um, let's see. This one. Okay. So basically, it's just the use of two main functions. That's the ORD, and that's there's the other one, the CHR function. Those two functions are the key things to make the Caesar cipher. All right. So this is actually the program to encrypt. This is the program to decrypt. All right. Now, it might seem complicated at first because all you see are just like there's no pattern, right? But let's try and dissect this one. So we have input here, right? This is our original message. Then we have the distance, right? Or the key, how many letters do we move the original message, and then the code itself. So the code is blank because this will be your encrypted message afterwards. Now we have a for loop, okay? For loop for the plain text. So we are accessing each character. Remember, we are accessing each character. So what do we do first? We convert it into ASCII. So this is what the ORD is for. So we're converting it into Sir Anthony. I think there's an echo on one of your devices. Okay. Thank you. So we first convert it into ASCII, right? This is what the ORD value is. And then we add the distance. Now we have the cipher value. Okay. This part is the one that's more confusing. Why? Because we're trying to um check if the cipher value is greater than or in Z. Now, why are we doing that one? Because the problem with ciphers, right? That it's easier for us to do if it's manual. Because what happens when we reach the end of the letter Z, for example? So what do we do with that, right? Z. Okay. Usually you should go back to what? Letter A, right? But how can you instruct the program to go back to A when you say add 3 characters to this one, right? So how are you going to instruct Python to go back to 97 when it's more than 122? So that's the problem that it's trying to solve here. Okay. Now, take a look. If it's greater than 122 or Z, right? What you will do is you will change the cipher value into something else. You would get the A, right? You would add the distance minus um distance minus okay, Z minus ord value plus 1. You need to add 1 because it's not starting at 0. So Z of 122, 97. This is for letter A. Letter A. Let's see. Mm, I'll try to get back to this one later on. But the main point here is that you should go back to letter A after if it's bigger than the character Z. So that goes back to A. It loops back to A. So I think there's something weird here. Let's just analyze this one later on when we try to actually make this run. All right. For now, let's just go over this one. But the logic is still the same. If you can, if you can find another solution where you can make it go back to 97 after it goes 122, then that's good. I mean, you can basically just use that one here. Like if it's greater than use the ord value of 97 plus the distance that was missing. So uh, you can do that, right? You have to take into account how many of the distance was used. Like you only use one of the 3 of the distance. We were left with 2. So if you were to move Z 2 times, it would be or Y, right? So 1, 2, or 3. It should be letter B if the original character was Y. So 1, 2, 3. So you can say that once it goes 122, the ord value should not necessarily go back, but it should roll over back to 97. So after this, it will go back to 97, 8. So if you can find a way to code it like that, then that's good. Basically, it's using that kind of algorithm here. I'm just confused why it's using distance minus and then divide here. It's a little bit confusing. I think there's something missing here, but we'll try to fix this one later on. But the idea is that, okay? That goes the same for the decryption here, the decryption code. So as you can see, it's using the same logic, but this time it's instead of adding the distance, right? It's deducting the distance. See, it's going the opposite way. So we'll do that one again. So the same thing also with encryption. If the cipher value is less than 8, then it has to roll over back to letter Z. The same thing. This is, of course, assuming that we're only using the character set of A to Z, right? That's another thing that you can keep secret from before. So now you need three things: the encryption, the character set that you're using, and then the key itself. So it might have been that you were actually using a different character set, or maybe you were scrambling the alphabet to make it more confusing, right? So instead of the standard A, B, C, D, right, you scramble it to make it look like C, A, D, G. So now when you move the letters around, it won't be the same. So it's easy to use that one if you have the character map, right? But yeah, more on that if we have time later on. Let's see. So here's an example of how those two scripts work. So we have invaders, right? Enter the CS3. You have this one. And then on the other side, if they have the encrypted text and the key as well, they get the original text. Again, this worked in ancient times, but it is easy to break in modern computer systems. If this is something that you like, then you can consider going into uh what do they call it, Lord? Security systems, those kinds of courses. Yeah, you might. So how is this related to data science? In a way, we can kind of like, let's see. Mm, Nothing comes to mind yet for now. How we can relate this one to data science. I actually haven't seen these things um before appearing in any data science data set other than user accounts. So yeah. There's one that's used a lot nowadays. It's called a block cipher. So if you actually take a look at your Wi-Fi connection, there's a part there that says AES. So that's Advanced Encryption System. And it's actually using a variation, I think, of block cipher. So it's a bit more complex, but it's still a kind of way of encrypting your data, right? All right, so here are strings and number systems, all right? So actually, there are functions already involved for how to convert between one number system to the other number system, right? What we have here is basically just an explanation of how to do these things manually. All right. If you wanted to do these things manually, it is explained here. All right. Sorry. So from this slide at the beginning here, after block cipher, up until to this is slide 16, up until this one, slide 26. So it is there that that's explained on how to actually um, convert from one number system to the other. But again, we already have functions for this one that makes it easier for us to actually do this. So let's see. If we were to convert, let's say for example, right, let's add binary to decimal. Okay. So if you want something from binary to decimal, all you have to do is use the int function, right? So how are you going to use the int function? So let's say you have an input here. Let's say temp is equals to input, and then enter decimal, right? And then the decimal value here will be in, and then your input, and then 2. So basically, what you need to indicate here on the second argument is the what they call that again? The number system of the one that you input. So if we um input a string, each string of bits, enter a string of bits. All right. So since it's bits, right? So it's the number system that is 2 because there's just two numbers, 1 and 0. So if you convert that to decimal, right? You need to indicate here that the original input is actually binary system. So if you print this out now, right? Closing parentheses, right. Okay, so let's say we have a string of bits. So 0, 0, 0, 1, 0. Okay, but the answer for this one is 2. And that is correct, really. So let's think of something else so that we can use this one as an example later on. So 0, 1, 0, 1, 1, 0. Okay, so let's review this one. 0, 1, 2, 0, 1, 2, 4. 1, 2, 4 is 16. 16 plus 4 is 22, 22. Yes, this is correct. So we'll use this one later as a comparison if we try to convert decimal back to binary. All right. That's for binary to decimal. Next is we have octal to decimal. So I just want to copy this one again. Enter. Okay, so octal from the word itself. So this is the number system is 8. All right. Let's look for one here. So this is for hex. Octal. Let's look for one here. Okay, so here's one. So 437. So 437. Okay. So the value of this one is 287. The decimal equivalent is 287. So let's use this one as a comparison later on. Okay. Next is we have Let's see, what else do we have? Oh yeah, we have hex to decimal. All right, now hex is actually all right. There we go. The hex is actually base 16, so we'll use base 16 here. And then let's look for an example. Oh, here's one for 3F. All right, for 3F. Oh wait, sorry, that was supposed to be an input for 3F. Okay, so the equivalent of that one is 1087. All right. So we have everything here from binary octal to decimal, hex to decimal. So as you can see, the decimal number is kind of like the intermediary of all the three. There's no function that will actually convert it directly from binary to octal or to hex or vice versa, or any of them directly to one or another. The decimal number is actually the kind of the middleman for them. All right. Now let's do the opposite. Okay. So let's start with decimal to binary. So for decimal to binary, what we need to do is so after the input, you're gonna use the function. This is the part where we have to use a different function. All of them earlier, if you just want it to be converted to decimal, all you have to do is use the int. In this case, binary. Uh, if you want the decimal to be converted to binary, you have to use the function called bin, right? And all you have to do is enter the decimal value that's here. So 10. In this case, this is enter a decimal number. Okay. Decimal number is the numbers from 0 to 9. Okay. Number 10 is a decimal number, but it's not one of its units, one of its characters. Okay, it's 0 to 9. That's decimal number. Okay. Just to clarify. So if we input 22 here, the one that we have above, they should be the same. What? Oh yeah, I forgot. So you have to convert this one first into an integer. There we go. And there we have it. Now you might be asking, sir, I think the output is a bit different compared to the one we have above. So it's actually correct. This one, 10110, 10110. The zeros after that are actually irrelevant. Okay. The OB here, the 0B that we see is actually an indication that what you're looking at is actually a binary number. So that's why it's 0B as an indication, all right? Because it can be that you might be looking at an octal or a hex number. It just so happens that they have the same characters. So you have to be careful with that one. So if it has 0B, that means it's a binary number. Okay. Next is we have decimal to octal. Okay. Let's just copy this one. All right. Now, instead of bin, what you have to do is use the oct function, OCT, and then just go with that directly. All you have to do is input the decimal number and you're good to go. So earlier we have this one, right? So if we input 287, it should give us 437. So it's actually correct. 437 and then 00 is an indication that what we're reading right now is a number of the octal number system. Okay, the same with OB. So OO is an octal system. Okay, and last but not the least is the decimal to hex. Okay, so obviously the function for this one is hex. And then if you were to run this one, we have 1087 earlier, right? And then a 0x43f, 43f, that's correct. Now this one seems more familiar to everyone, right? Because in one way or another, you must have seen some errors on your devices, like the blue screen on your laptops or PCs, or even in your phones, you might have sometimes where the app crashes and then it tells you some kind of number where it starts with an OX. So what you're looking at um there is actually a hex number, and it's usually pointing to a certain location on your memory. So this is a good indication that there might be something wrong with your memory. All right. So if it says cannot get the data from this memory address, for example, then if it keeps on repeating in that same address, then it might be possible that there's damage in that area. All right. So what do they do? Usually if it's um I think you can isolate that, but I forgot if there's a fix like that where um you can only use certain parts of your memory. You'll not be using the damaged parts so that you can keep on working. But I forgot. But that's the main point here. You might be asking, sir, what's the reason for creating those number systems in the first place? So binary is uh really simple because it's what the computer understands. So it really needs that one. But what about for the octal text? So as you can see, right, for the hex number, you're using 4 characters to represent a number for decimal. If you convert this one into hex, you'll just be using 3 characters, right? So that's a big difference, especially in systems where memory is limited or is scarce. So, where do we see systems like that? So nowadays they don't really exist. But it's actually the case when it was the 90s. So, um, let's see. So back in the 90s, if you remember, I think I discussed it one before, the, how to say this, the memory was very small, right? Like just how many MBs, and now we have gigabytes and gigabytes of memory. So, uh, so it's like we don't really need this one anymore, but in some cases it still exists. So I'm not really sure why it still persists today. I guess it's because it's I don't know. Really. It's I think it's a lot easier also to like isolate properly. Like if you're using hex, this is primarily used for memory addresses because those addresses are really long. If you think about it. So I think the hex number is still very useful because you can compress it into very few characters only. Um, so yeah, in any situation where you need to convert from any of those number systems, then you can use these examples here as a reference. But if you really need to understand how they work, like how I did it earlier, counting it manually, then you can refer to the PowerPoint and look at the discussions in those slides. Okay. We won't be going through that since you won't actually be doing that in data science. You'll actually just be using the functions themselves. So that's okay, right? Um, and with that, it's almost 3. So I guess we'll have a break for now, 15-minute break. I want you guys here to be back by around 3:15, and then we'll continue with our discussion. Okay? All right. So have a good break, and I'll see you guys in 15. Okay? All right. I hope you guys are here. Hello. All right. And now we are here finally on the string method. So we kind of had an introduction on this one earlier a little bit with methods, right? Now, with methods, you have to understand again what are objects and then what objects are, right? And I usually explain this one using an analogy. So the usual analogy I use is for the car. So for example, let's say the car is an object, right? Now an object is made out of properties and methods. Okay. Now properties are things that describe the object. So for example, um, what can we say about the car that describes it? So uh, its color, you can use the color, its make, its model, its what type does it use? Does it use steel or carbon frame? Does it have like mm, just as long as it's something that describes the car. Now we also have things in the car that are kind of like its features, right? Like things that it can do. So that's what the methods are, what it can do. So what can the car do? It can accelerate, it can brake, it can have an air conditioner, it can have radio. So those are the things that the car can do. So those are methods, right? Now, if we translate that one into um, programming, right? Let's translate that one into programming. So our object, if you remember at the very beginning of our lessons, I told you that almost everything in Python is a object. Now let's try and see that one. So if I were to say we have a string, right? We have a string. Now, if I were to tell you guys what are the properties of a string, one of those would be how many characters it has, or in other words, the length. Okay. Now this here, this value 6 is actually a property of this object. Okay, it describes this object. It has 6 characters. Okay, now what about the method? Now you've seen an example of this one earlier, right? So if you say print temp dot lower, okay, these are the things that the string can do, right? It can use the lowercase. It can use the uppercase. Okay, to convert itself into its uppercase format. See? So if you think about it in those perspectives, it becomes easier to understand what are properties and what are methods and how to identify them. Okay? So now you know what properties and methods are. Okay? The only thing that you have to remember is that the method, okay, will work only on the object that it is acted upon, or in this case, the temp here. Okay? So this upper, right, will work the same way with other strings, but in this specific example, this will only work in this string. If you have another string here, let's say you have temp2, right? Example here. All right, and then you have temp upper. It doesn't mean that the upper here will work on sample. That's not the case. All right, this will only work on this one. If you want, you can have also temp2 dot upper. So that's how you would do it. Okay. It doesn't mean that what I'm trying to say is that it does not go to other objects. It only works on the object where it belongs to. Okay, so remember the car, right? The car we have its properties and its functions, right? So you can't have a car that that has an air condition that turns on the air condition of the other car. I mean, you can technically if you force it, like I don't know, like a communication or whatever. But the main point is that it only works on that specific car, right? The controls there. The same thing with methods, okay? Um, so that's the idea, okay? And we always do these things, okay? The dots here. This is actually called the dot method. It's called the dot method, okay? And that is our way of accessing properties properties and methods. Okay, now we know how to access methods. What about properties? So in this case, how do we access properties? Okay, one way of doing that is to actually see all the properties of all the properties and methods of an object. So if you actually say something like dir and then temp. So the dir function is universal. It can work on anything. Let me just remove these two here. Okay. So if you say dir temp, it will list down in a list, right? All the properties and methods. So if you actually explore this one a little bit, you'll find on the lower part here, lower, and then where is it? Where's the other one? Upper. See? So the methods that we already know already exist here. So how do we know um, which ones are properties and which ones are methods? So usually, this is a good indication. The ones with um, the ones with underscores are usually the ones that are properties. Okay, it might not always be like this. This is just for Python. In other libraries or frameworks that you're gonna work in the future, they might have a different format or they might follow what Python has. Okay, you can actually decide for yourself how you want it to be um represented. Okay. Now, how do we access properties? So let's say, for example, init here. Oh, no, let's look for something. How about size of? Okay, size of. I think this is a safe one. I think for the others, it's not really that straightforward. Size of. Okay, let's try and access that one. Okay, so temp. How do you access properties and methods? Use a dot, right? And then size of. Okay. Now, if you do this, what it will return is that it's a function. Okay, it says it's a function string size. Oh, so that means this is actually a function, right? 47. Now it looks like a method, right? But don't get confused. It looks like a method, but it's still a property, okay? Because it's not doing anything um, to the object. It's not doing anything, right? It's just telling you the size of the um, object. So in this case, I think it's 47 bytes. So that's how big the memory that this one consumes. In that sense, why does this one look like a function? So technically in other languages, you don't need this one to be a function. The reason for this is for security purposes or just to make sure that you don't accidentally um, change the value of the size of the object. So when this object was created, right, it also automatically creates by default all those um, properties and methods because it kind of has this kind of template, okay, this kind of blueprint. We call this a class. The same way we create cars, right? It comes from blueprints, the same method. Objects comes from blueprints, and there is a blueprint for strings. And when the string was created, when we say earlier, uh, when we say earlier that temp is equals to Daniel, right? The moment that we indicated this one, it was automatically created for us. It just so happened so fast. Okay. Um, so that's what we see. And then hold on. What happened? Ah, uh, sorry. Sorry. Where was I? So it just protects the user from accidentally modifying the actual value of the size of because when this was created, the properties was also populated automatically. So the only way to access those values is to use the function. Okay. So we call this the setter and getter methods. It's a bit more deep, but basically you don't need that one for now. Just understand that in this case for Python, whenever you see that one, if you're trying to access a function, oh no, wait, a property, and it says function, it describes that the size of is actually a function that um, has this kind of syntax. See, string, this is our string, and then size of. It's basically telling you how to use it. Okay, so now you put open and close here, and then you get the idea. Okay, so that's the idea of strings and methods. Okay, and over here, let's see what it's using. It's using split. Okay, now the split actually will, let's see. It will split the words into list. Okay, like for example, if I have a sentence here, um, the brown fox jumps over the fence. I wonder, is that the correct sentence? So if I use print and then sentence dot split, sorry, forgot. There you go. So it will split it out in terms of whatever is your splitter here. So in this case, the default is space. All right, so that's why it splits across the space here and then inputs it as individual items. Okay, now this is very useful in cases where your data set, in some data set, it might be using, sorry, it might be using colons, for example. So this is the part where data transformation comes in. And this is actually a key skill that you need to learn in data science. Okay, although later on we also have another library for this, it doesn't mean that that's all that we have to use. So we're going to have to learn methods and other properties in Python as well. So for example, this one, you want to tell Python that you want to separate the strings in terms of their columns. So if you put the string colon here, right, and then use that one, as you can see, the output is still the same. It will read out, okay, and split it between those characters. See? Or it might be that in some of your data sets you have dashes, or most commonly for file types that are CSVs. CSVs. You know what CSV are? So this is short for comma separated values. So this is usually what comes from uh, Excel, right? You can use this one for Excel. Actually, it's not just Excel. There's other programs that use this one. It's just that it's easy to send this one over the internet without much effort in CSV values. You can send this one in text format and text in Notepad and then convert it into Excel. It's very easy. Um, you could even use Excel for this, right? And there's a function in Excel where you have to separate it depending on the character that you want, and then split it up, right? There's one there. So in this case, we're just using Python, using code. Okay. What else? So yeah. So we're comma separated. Of course, you're going to be using comma for that one to separate the values. Okay. Now, in this example, it's just pretty simple. It's getting some list of words, input a sentence. This is the sentence. The sentence has no long words. It splits it out, and then it will check, right? If you use a len on an array, for example, like this one, it will just count how many items there are. So just like with the string, this one has 1, 2, 3, 4, 5, 6, 7. So the len for this one is 7. There are 7 smaller data samples inside of this data structure. Okay. Um, so there are 6 words from this one. And then we have a sum here. It's set to 0 at the beginning, and we have a for loop. Now, what it does is it counts how many word length of word for each word. So it's counting how many characters are all in all in each word. The total sum, and then it's getting the average word length. So it's just the sum over how many words there are. So that is the average word length is 4.5. It's not really useful for us. I don't also use this one, but it's just an example. And, the main point here is the split method, how it's used. Okay. Um, Yeah, this is basically what I discussed earlier. We have the help. So how do you use the help? Aside from the internet, there might be cases where you have no internet, right? It might happen. So how do you use the help? So for example, like earlier, we have this one, right? Let's go back to DIR. Okay. Let's go back to this one. Let's say you don't know how to use is ASCII, for example, right? And you want to ask for help. So all you have to do is help, and then start with the string or the object, followed by the dot, and then whatever you want here. So is ASCII, all right? But we know that this is a method, right? What's important is that you don't execute the method. What do I mean by that? So when you put an open and close parentheses, you are telling Python to execute that function. That's not what we want. We want help. So just disregard that one. You just need to tell the help function what it is that you wanted help from. So you say temp is ASCII, enter, and then it will give you something like this. Help on built-in function as is ASCII. So this is a method of built-ins dot string. See, this is a method of built-ins dot string. So this is the blueprint that it came from, that it created the string. Okay, blueprint dot str instance. So meaning this string, right, is just an instance of the original blueprint. Yeah. And then return true if all characters in the string are ASCII, false otherwise. And it even has more description here. ASCII characters have code points in the range of U plus 000 to U plus 007F. I think this is hex. And then empty string is an ASCII too. Yes, remember, even a space is a character considered as a character, so it has an ASCII character too. The range here is saying U because it's using Unicode in this case. That's why it has U there. So that's it for help. Okay, remember not to trigger the function. Just put the function there as way of telling Python, this is what I need help with. So yeah. All right. So here it is, a more dynamic way of using the split, using the dot. Um, you can split the file name into its extension and its file name itself. So .text, .py, .html, see? And then after that, since we haven't gone there yet, but for the lists like this one, the subscript operator actually works the same way because remember what the subscript operator does? It works on a data structure, right? Like the list. Okay, now or the string, right? But a list is also a data structure. So technically it can work, right? And this is what we see here. If you're using a subscript operator on a list, like this one, it's using -1. So using what we know, this subscript operator will now have access to this one, the last character. Since we know on the last character, the last item on the list, we know exactly that the last item on the list will be the extension of the file name. See, so that's why it's using -1. It's not using 1 and 2 because 0 and 1 because there might be a case where the file name is myfile.2025 or .6.20.2025.html. It can be like that. Some file names are like that. Um, so it's just um, a way of anticipating the different kinds of inputs. But it can be, but it is sure that it will always appear at the end. So this is one useful thing for negative indexes where you're absolutely sure that it will appear in the end. Okay. Um, what else? Text files. Let's see. All right, so this can be useful for us because we're gonna be opening and closing the files in um Python. So what I need you to remember here is that the methods that we're gonna learn here are basically uh, a way to mimic how we users would open the file. So how do we open the file? We double click on the notepad, for example. We input some data, and then we save, and then we close. That's the general step, right? We're gonna follow the same steps, but using programming because we're gonna be automating the things that we're gonna do, right? So imagine we're opening 10,000 notepads. Okay, so that's impossible for a human. It is, but it's such a waste of time. You can just let the computer do that one. So what you need to do is to be very precise with your instructions. Open, get the data, save it, and close it. Go to the next file. Open, get the data, close it, save. Oh, I think I mixed the two, but you get the idea, right? You need to automate the procedure. All right. So here we have, let's see, using a text editor and create view. So this is one thing that you need to remember. All data output to or input from a text file must be strings. So when it says text file, this is just a regular text file from the notepad. those things that you can usually open up with just a notepad, must be strings. So if you have numbers, you must convert that one first. Okay. So this is what we have here. Um, all right. So we have two methods, three actually, that are um, the things that we most need. So open, write, and then close. So from the name itself, those are the different steps that we indicated earlier, right? When you say open, it has two arguments that it needs. It needs the name of the file that you want to open and the mode that you want to open it with. So if it's W, that means it is in write mode. When it is write mode, what you have to remember is that used for creating or overwriting a file. So if you have existing data, you would not use W. You would use A. So that is for append. Basically, there are just three modes that you're gonna have to be aware of. It's W. Um, it's W for write. We have A for append, and then R for reading. So those are the three, basically the things that you will most likely need. Okay. All right. Now, just be sure that there's no existing data, otherwise it will be deleted. Okay. Now, next is you will have to write this one. So if you can see, it's using slash ends to indicate the enter key or the new line character. Go to the next line. Okay. And then finally close it. So why do you need to close it? It's because when it remains open, it uses up memory. The same way as you opening up a notepad and not closing it in your desktop, it will consume memory, even though it is minimized. All right. The same thing with programming. So you have to indicate that you have closed it. Okay. All right. So if we try this one out, okay, if we say, yeah, we say F. So F is just the name for our variable. Okay, so um we say open, right? When you go and read the description of open, it will say that um it will create an object. All right. So basically you can treat this one as something that has the blueprint, okay, to create a file object. So the open method or the open function will create a file object. So meaning the F here now becomes a file object. So take note of the name that I used, okay? File object, not a string object, not a list object, a file object. So it's different. Um, so when you say file open, and then let's just use the example here. My file.txt, all right? My file.txt, and then write mode. So that's okay. I know it doesn't exist. Where is my file.txt? So if you indicate it here like this, it's actually looking at the um where you're running this script from. So this script, this notebook is this one, right? So that means if I type out my file.txt, it's gonna be looking for that here, somewhere around here in this folder. So we know that it doesn't exist, right? You can even see it that it doesn't exist, right? Okay, so let's complete the program. F dot write, okay, test slash n slash n test2 slash n. Okay, and then f dot close. Okay, the moment I run this code, we should be able to see the new file here. And then when we open it, we should be able to see the text test and then test2. All right, now when I run this, you won't see anything. Okay, Nothing, right? I just ran the program and nothing happens. But when you go to the directory, you will see my file.txt there. Okay. If I click on that and then double click, all right. So it opens the my file.txt and you can see that it's over there. Okay. Now, as an example, we have to edit this one. Okay. Edit it. Let's put one line there. Okay. Now, if I were to close this one, save text, close, just to make sure it's still the same. See? Now, if I run the code again here in W mode, in write mode, and then I run it again, if we go back here, it looks like nothing happened. But if I open that file, you can see that the edit that we made disappeared and then it was replaced by this one. Okay? So you have to be careful with the W mode. All right? So it is used for creating or overwriting. So that's it. That's for opening, writing, and closing files in Python. All right. So this is just an extension of what happens. So when you open an integers, right, you have to, we're just basically writing random numbers at this point. See, random dot grand int 1 to 500, and then convert that number into a string using the string function. See, just remember, what comes in and out of a file object must be in string format. So we have to convert that number into a string. See? All right. Uh, so now you would have a file that has those kinds of numbers. Okay. It's using a random library here. So again, this is an object. Okay. And since it's an object, you can treat it and use the dot method on it. So random dot rand int. See, does it make sense now? Okay. Um, let's see what else do we have here. So f dot read. Okay. Now the read here, um, the read here will basically read the whole thing. So if you have the whole file here and then you ran the read function, then it will get the whole file and then save it to memory. Basically, e everything, all the content is in one variable. Okay, in this case, it's the text here. Now, this might seem fine for now, but what if your text actually contains a lot of things, right? And you need to process each one. So at that point, the read is not really efficient because you have a variable somewhere that is too big. There is a additional method for this one, and that is actually called the read line. See, and then the read line is just for um from the name itself, you're just reading each line. So instead of opening the whole thing, it will read this one first, and then read this one next, and then read this the next line afterwards. Just like with a for loop. See, what this is in this case, it's just using a while loop. So line is equals to f dot read line. Okay. Now Python understands that it needs to pause at that line. Okay. And then if line is equals to blank, break, otherwise, it will print the line. Okay. Now this is the output, first line. It goes back to the beginning. And then it checks again line is equals to f dot read line, but this time Python remembers because this is what we call again. It's the same with the range, the range will only generate numbers every time that it is called. That's also for the read line. Every time that the read line is called, it will go to the next line until there is no more line to read. And that's our base case here, where line is equals to blank. Basically, there's nothing there else that follows, and then it breaks. So as you can see, the example here is just first line and then second line, and then after that, it stops. All right. So the reason why I'm going over this one is because the odds are, most likely you guys will be opening notepads. There might be cases where you might be opening notepads for data science, but usually the data sets that I've encountered are either in Excel or in other formats. Not it, if it's the CSV, then if it's CSV, then you can actually open that one in Notepad, but in Python, you need a different library to read CSV files. So the one that you see here is mainly for TXT files. Okay, the thing that you see here is just the open method is just for TXT files. All right. If you want to open some other extensions, then you're gonna have to use other libraries as well. So if you want XLSX for Excel, it's a different library. If you want docx, if you want PDF, there's a lot of libraries out there. You'll just have to choose the one that you want, okay? But the same process almost always goes. You open the file, you read it, and then you close it afterwards. Usually it's just like that. But you have to read the documentation again. We'll get to that soon and how to view the documentation of different libraries. All right. Let's see. So in this case, the integers.txt that it created earlier. So if we're reading that one, see line, let's see. And float the sum for line and f. Ah, okay. So this is other than read and read line, you can use a for loop. The for loop will automatically function like a read line. Okay. So for line in f, this is our object. It will read each line automatically from the file. Okay. So you can use that one, access each line and then strip it out and then convert it into a number. See? So, I don't know if you guys have seen a pattern, but usually it's some form of these steps. Like you have the data, you need to get the data from what, right? So in order to get the data, you need to either split it or identify where it begins and then use a substring to get the data. Or if it's a number, then you have to insert a line of code where it converts it, right? If you're seeing the pattern that is almost um always the same, right? There might be different sequences in the future, but the point is um it almost everything looks similar, okay? In a way when you're processing the data, um the methods that you're gonna use are just gonna be going back over and over again. Okay. All right. Uh it's the same thing. All right. So as you can see, it's just a summary of the things, the functions that we're going to be using for opening a file object. So open, close, write, read, and read line. For the read line, you have the for loop as well. So you do that one. Um, to do that, I would say that to read each line. Okay, if you want a more uh plain way of accessing each line. All right, so in order to access different files and directories on the disk, you have to be familiar with how to refer to them by their path names. Okay, so in our example earlier, this is our path. Okay, in this sense, in this sense, we're just referring to it because it's located here. But what if it's located in another location, right? So we have actually names for that one. So there's two absolute path names and relative path names. So absolute path names start at the root directory. So this is usually the ones that start from the drive. So C colon slash slash, those kinds of things, okay? The absolute path name. Or you can use the relative path name, in which it's referring to the working directory or where your script is located. So this is our script. It's located in this folder. So this will be our working directory, okay? And let's imagine that's where we are. See this thing called current. So if you have, let's say, if these things are folder, the dark ones are a folder, and then the white ones are the files itself, okay? So the current is the folder. This is the current folder, okay? And then you have the child here. So these things are the child, okay? If you go to the child, then you can just access them directly, like this one, like this, directly. If you go to the sibling, all right, you have to indicate the sibling first and then the file, okay? If you go to um another child folder, then you have to indicate the child and then the file name. If you go to the parent, then you have to indicate the parent directory and then the file name. So it might make more sense if we have some examples here. So let's say we want to go to sibling. Oh no, wait. Let's do something simpler. Let's create a new folder. Okay. This is actually the current folder. Let's just create something called the current folder. And then beside the current, we have what? We have the sibling, right? Sibling. Okay. And then the parent is actually this one. This folder will now be the parent, right? So up the on the parent we have my file.txt. On the current, we also have my file.txt. So let's can I copy this one? Copy current paste paste, all right. This is my file in current. This one is in the sibling paste. I said pasting, copy, sibling, paste. And then this is for the sibling. Okay. And then this is for the parent. All right. Now, assuming that we are in the current working directory. So we're going to create a new Python here, a Python library, just to simulate the experience, right? So this is where we are currently, all right? And we want to access this one. So if we just copy this format and let's put this one in read mode and then print it out. No, so let's just print this one out, f dot read, okay, and then what's the file name? Current, my file dot current, all right. So if we run this code, we can see that it runs perfectly because this Jupyter notebook is this one, right? And since they are in the same working folder, you can just call it directly. Now, if you go back up to the parent and then call the parent file, you have to indicate something like this. So slash, and then what's the name of the folder? Name of the folder is batch 18. So batch 18, and then slash, and then what's the file name here? My file dash parent. My file dash parent dot txt. Okay. Now, if we run this code, it will produce an error. What's it? Backslash. Oh wait, we're using double dots. All right. So for the parent, you indicate double dot and then slash. Okay, there you go. So now we have access to parent. So this is actually the code. Um, you go to the parent, right? Two dots and then slash. This is for relative directories. Okay, the one that I did earlier was for absolutes. Uh, I was lacking a certain part where I needed the beginning part or the one for the directory part. I was missing that one. Um, so that's for the parent, right? If you go to the sibling, so you have to go to the parent first and then access the sibling folder. So all you have to do is go to the parent first, double dot forward slash, and then sibling, and then slash again, and then access the file. See? So now we have access to the same content. But this time this is located in the sibling folder. Okay, so that's how you access different directories in Python. Okay, anything more than that, then you will be using absolute path names. So um, yeah, you're gonna be using a longer string to refer to the file name for that. But if I remember correctly, you'll also be using the library for the operating system because it needs to connect to your operating system to know where the file is located. So I think it's also shown here. Yes, so import OS, the OS library, and this is what we need. List directory. So you need the directory of the current path that you have, and then you add that one, the file name at the end, and then you get the total file name. So, uh, yeah, let's see. So it doesn't really show the example here. It's just asking for list. List there are actually just list all the files in that directory. Get CWD as the current working directory. That's why it's CWD. Um, Actually, we can try this out. So if you say import OS and then temp equals to OS dot get CWD. No, wait, we print this one out. Temp, there you see. So it will show you the entire address. And then using this one, using temp, you add in afterwards. So if you were to use this one in the open function, you would input temp there. You would add the two strings. So you would say temp plus and then the name of your file. So that's how you would do it. If your file is actually located in a folder that's further away. Okay. Um, for the other things, you don't actually need this one. Change dir You're looking for the current working directory. You're changing the directory. You're listing all the things. You're gonna make a folder. That's why it's make dir. You're removing a path. Essentially, you're deleting something. Uh, but this is for files. This is a path. Yeah, this is for files. RMDIR or remove directory is for deleting folders. So this is for files, this is for folders. Rename is for rename, and then set is for um let's see, it holds a separator character. It's either gonna be forward slash or backslash. It depends on your file system. Again, I don't really use these things a lot, mostly because the type of data sets that you're gonna get is usually in a different format. So it's not usually, besides, if you have the data set, you should just put it in the same folder, right? Why why would you put it in a different folder that's further away? So it makes no sense, right? Usually it's in the same or current working directory that you're placing your data sets in. Okay. Exist is just for testing if the path exists, if they are, if it's a directory, if this is a file, the size of the directory, and then the normal case. Um, I don't, I don't actually have to use this one before. But for a quick processing, for example, for reverse process, the backend is the letters to lowercase on a Windows system. Hmm. Okay. And that's it. We're in the chapter summary. So it actually took us quite a while to finish this one. All right. Do you have guys any question before we go to the next one? Neil, Paula, Anthony, are you guys okay? Or was it too much information?
Okay lang, sir. Medyo information overload, pero it's okay.
All right. So there's a lot of things to learn, but just keep at it, and I'm sure you'll do fine. So don't worry if you don't actually get it in just, in 10 sessions. Because when I was learning this one, it took me 2 years to learn the whole thing. Um, you say, and I was actually self-study on this one, so I did it by myself. So it's actually great for you guys if you have mentors or classes like this one, because you can ask questions and, know the shortcuts. But yeah, programming, I mean, for Python, you can actually learn this one in just a day if you're really at it. You can learn everything in a day. You can be familiar with it in a day. But again, programming is a skill. It needs time to actually develop that skill. And that's the part where others tend to give up on because the more that you learn, the more you realize that it never really stops. And then the field is constantly changing. There's always new things. So if you're not up to date, then you're kind of like lagging behind, those kinds of stuff. And then there's also imposter syndrome. There's a lot of things that can go on. But, just go at it a little bit every day and you should be fine. All right. So let's me open up the other file. Uh, all right. List and dictionaries. Okay. So technically, this is the last one for the PowerPoints that we're gonna discuss. And then you should be done with Python. The last PowerPoint for functions here is more like um extra things. You see, design with functions. So yeah, technically this is the last part that you're gonna need. So list and dictionary. So finally to the most to the topics that we have left, right? Um, we've seen some examples of this already for list, but not really with dictionaries, right? So we'll go with that one. Okay, so we'll start with list. All right. Now again, list is data structure, same with dictionary, but it has what? It has a sequence of data values of any data types. So again, you can mix and match them if you want. If you have a list here of a number, of a string, what's happening? Of a number, right? Of a Boolean, right? You can mix them up however you want. But again, it doesn't really make sense because if you loop over this, right, you can't use those methods anymore. Like if you have string and then upper, this won't work anymore for a number, right? See, it's going to produce an error because int is not, the int object has no attribute upper, right? So methods and properties, they call it attribute, right? It has no upper because that method doesn't exist for numbers, right? So it doesn't make sense if you have multiple data types here. Although you can, it doesn't make sense why you would want to do it in the first place. Ah, okay. Uh, where was I? Why is this still here? And a dictionary is something different because it organizes the data by association. So you'll learn more about that later on and why it's um one of the most powerful things that you can use in Python. Okay. So lists and dictionaries. If you really think about it, okay, you'll learn this one later, but a list actually just comes from dictionary. So you can say that dictionary is kind of like the all-encompassing thing for all the different types in Python. And then since the others are just used a lot, that they made something different for that. So it kind of like it made a segue from dictionary to list because since it's used a lot, why not just make something different that is already set up that way? Okay, kind of like that kind of logic. So that's why the list was born. Um, let's see. So we call it list and dictionary, but in other languages they have different names. So for a list, it can be called an array. For a dictionary, it's just called objects. Um, Classes usually are the same. So yeah, if I remember, there's no other name for classes. It's just class. So those are the blueprints that I mentioned. Um, Yeah, from what I can remember, it's always either of those two things. If it's not list, then it's an array. If it's not a dictionary, then it's an object. Okay, but it doesn't mean that that's the only data types and data structures. Remember, you can create your own data type. You can create your own data structure. You have to be flexible with that one. Okay. Okay, so these are the lists, and here are some examples of the usual list that we do in real life: shopping list, to-do list, roster, guest list, recipe, right? And then we call each one items or elements. Okay. And then each item in a list has a unique index that specifies its position from 0 to length minus 1. Okay. Basically what we discussed earlier, right? If there's something that I have to discuss, it would be that lists are, there are some properties of lists that comes to mind. So when you see a list, it is what? It's ordered because of the way that it's structured, right? It's ordered. It's mutable. When you say mutable, when you hear the word mutable, it means that you can um change the values or add or remove items at will. Okay? That's what it means to be mutable. Um, what else? It can have a mix of data types and then of course accessing it using the substring operator. So that's one of those things. All right. Here are some examples. Okay, as you can see, this is a list of strings. This is a list of numbers. See, even a list can contain a list. A list can contain a dictionary. A dictionary can contain a list, and it can even go levels deeper than that one if you want. What else? So when an element is an expression, okay, it has to be evaluated first, just like what happens with functions, right? Anytime that Python sees an expression, it has to evaluate that one first. So here we have the math object. It's using the square root because the square root is not available by default. It's looking for the square root of x. Now, when Python sees this one, it evaluates that one first, and then that's the time when it assigns it to the list as this number, okay, a floating point number. If it's x plus 1, then it has to process that one first before it becomes something like this. Wait, okay? Again, anytime that Python sees an expression, it evaluates that one first, no matter where it is, okay? Inside the list, inside the function, for loops, okay, that's like if you have like um what do I call this one, like an order of what to do first for Python. If it sees an expression that's on the top of its list, it does that one first. Okay. Next, we have a list of integers can be built using range. Yeah, if you remember, range can what? Range using the list combined with the list will create of course, a list, right? So it can use to build a list of integers quickly if you want, and then also for strings like this one. See, so everything has been explored so far before, right? Or discussed in some way. Um, let's see. Len, subject operator and plus, and we will work on lists. So if you say len, the first that it means here is this one. This is the example it that 1, 2, 3, 4. So yeah. So letter first, you can see there's 4 items. Subject operator and zero index, it's 1, that's correct. And then 2 to 4. So it will also output a list, a 3 and a 4. See? So 0, 1, 2 to 4, 3. 4 doesn't exist, so it stops here. Um, That's why it shows 3 and 4 here as a list as well. Okay. If you're using equal equal, that will also work. As you can see here. So first plus 5 and 6, that will be equal to 1, 2, 3, 4, 5, 6. But if we say is first equal to second, that is also true. Can you tell me why? All right. So this is the value for first. This is the value for second. And if you see, the results are the same. Okay. So at this point, it says the first is equal to second, so that's why it's true. Okay. Um, if you remember, this is just we're just concatenating the strings. We're not assigning them to something else. Okay. So here we're just taking a look at what happens when you concatenate the first and then the list 5 and 6. So this is what it will look like. Okay. Um, but the value for first and second did not change. So that's why it's still true. To print the contents of the list, you can just do directly with the print. That's fine. And the in operator is also works for the list. So if you're looking for certain items, right? If 3 is in that list, it can do that one. If 0 is in that list, it will see that there's no 0 there. Okay? So almost everything that we have seen here has been discussed, right? And also demonstrated. So nothing really new so far, other than we're more focused on lists at the moment. Okay. Again, the list is mutable, so you can insert, remove, or replace things in the data structure. The list itself maintains its identity. What do you mean by identity? That means it's still a list. That's what it means. It did not become a dictionary or something else. It remains to be a list. But its state, its length, contents can change. Okay, as long as it doesn't change from being a list, we call that maintaining its identity. Okay. Now we have the subgroup operator. It's used to replace an element. Okay, so very simple. We have a list. We change index 3 to 0, and this is what we have here. See? So at this point, we are directly changing the value for that item in that index number to 0. That's why we have 1, 2, 3, and 0. Okay. So again, the subgroup is used to reference the target of the assignment. Um, but this is not on the list, okay? Which is not on the list, but an element's position within it. Okay. So 0, 1, 2, 3. All right. Oh, Neil actually has a message. All right. Okay. I didn't say goodbye. That's okay. Um, anyway, this is recorded, so you guys can just review this one in your own free time. Uh, let's see. What's the next one? So after this, it shows how to replace each number in a list with its square. Okay, so let's take a look at the example. So we have numbers here, right? We have a list. It's just showing the output, showing it in the output. And then we have a for loop. So for index and range of len numbers, and it's accessing the numbers index and then assigning it back with the square of that number. So that's why we have 2, 4, 9, 16, and 25. See? So remember that this is a for loop, right? Each time that it loops, the number on index changes, right? Based on what we have here. So range of len of numbers, what is this? Len of numbers is 0, 1, 2, 1, 2, 3, 4, right? So meaning the range here will give out the indexes 0 to 3. And on each iteration, 0 to 3, right, it will assign each one of those numbers to the variable index. And since we are accessing them by using the index variable, okay, that means this code here is now dynamic. So it changes automatically when the index value changes. So numbers 0 is equal to numbers 0 to the power of 2, right? So we're automatically assigning it back to the same index that uh right originally came from. So 2 to the power of 2, it's 4. See, so they're still in the same position as before. because on each iteration, the index is changing, right? And it's assigned in the same location as well. So that's what's happening here. In this one, in this example, we have a sentence, right? And then we split that sentence. Remember what happens when we split? It becomes a list. So we have that list here, okay? Now we are looking for range len of words. So len words is 1, 2, 3, 4, 5. Range of that, so that will be 0 to 4. That will be the values of 0 to 4. So those are the index numbers, right? So we're going to access each word now using those index numbers from this list and then convert each one to upper and then assign them back to that specific index. And this is the result. This example has 5 words. See? So fairly straightforward, basically. Um, okay, before going into that, let's do a quick example just for reference. Okay. All right, so let's say we have a temp list here. Let's, oh, what happened? Okay, just random numbers, maybe 3, 6, 8, 4. Okay, those numbers. And then let's say we just want to add a 3 to each number and assign back to the same location. Let's say that's what we want to do, okay? So we make a for loop for x in what? We make a range function using the len and then pass here the list that we have to create to generate all the indexes possible for that list. Okay. Now we go over each index of that list and then assign it back. So we say temp and then 0, right? So what is 0? That's x, right? At this point in the iteration. And then what do? We just add 3 to it. So temp x, whatever temp x is, plus 3, and then assign it back. And then automatically that's what it will do. If we print out temp again afterwards, that is the result. So 6, 9, 11, and 7. You see? Exactly the same thing as our examples earlier. All right. Now we go to the different methods for inserting and removing elements in a list. So we have append. So this is for adding elements to the end of the list. End of L. L here is the list. Don't get confused. Other libraries have this kind of trick that makes it annoying. They say L dot append. So you have to figure out what is L. So usually, remember, the dot method is used to what access properties and methods of objects. So you have to identify what object this is. And usually it's in the description. It says that um, blah, blah, blah of the blank object. So that's your key. That's your cue to look for that object in other parts of the library. So we'll get to that soon in reading, how to read different libraries. Okay? Because it can get quite confusing real quick. So we have extend. So basically, it's just an extension of a list. Similar to what happens with concatenation. This one here, L dot insert. So we have index and then element. You indicate where you want to insert the element and what index you want to insert it. Pop returns the element at the end of the L. So if you have a list, right? If you have an item at the end, if you say pop, you just get the item at the end. And then if you indicate the index, then you are specifically indicating in what index you want to get the value from. So why are these functions here, right? What's the difference between using them and using subscript operators? The difference between them and using subscript operators is because usually when an error occurs, there's there's some method in some functions available where the program can still continue even though there's an error encountered. So that's really important because there might be some cases where um, you did not expect. So you have to be sure that your program will continue to run. Otherwise, you're just wasting hours and hours each time that you're running your code, right? So let's say, for example, for 10,000 notepads, you're running your program, all right, and then it discovers a code. No, it discovers an error and it stops everything. So all the work that it's done is now what? Gone. Okay. So what you need to do is find a way for the program to continue even though there was an error. And that's usually where these functions come in, even though they have the same impact as using subgroup operators, right? Like for the append, they can just use the subgroup operator to add at the end, right? That's one of those things. Or the pop, get the one from the end and then um, delete it afterwards. You can't do that. So that's the reason why these functions also exist. All right. Next is here. So the method insert expects an integer index and a new element. So we have an example list here, 1 and 2. And then if we insert the number 10 at index 1, this is what will happen. So 0 and 1, 1 is here, right? So everything, all the numbers starting from this one will be moved to the right. And that's why we see number 2 move to index 2, 0, 1, and 2. See? So just imagine a 10 is being inserted there and then pushing everything to the right. So that's what exactly what's happening. Okay? If you insert 25 at 3, which doesn't exist, 0, 1, 2, 3, right? Doesn't exist, that's okay. It's just inserting that number there. Okay? In this case, it's not going to be an error. Okay? That's for insert. Append here expects a new element and then adds it at the end of the list. So the same example, 1 and 2. If you say append and 3, it will be added directly to the end. Okay? Now extend, as you can see, example 1 and 2 will be extended by 11, 12, and 13. Oh no, wait, example is now 1, 2, and 3. So 1, 2, and 3 extended by 11, 12, and 13. We have this one. All right. So let's see. Where was I? Oh yeah, so 1, 2, 3, 11, 12, and 13. So exactly the same as what you would get with a concatenation operation, right? Um, on the next example here, example plus 14 and 15. So as you can see, it's doing the same thing as extend. But again, we're not assigning this one to example, right? So as you can see, example is still the same. You're adding the list 14 and 15, okay, but it's not doing anything to the original object, which is example. Extend here will automatically modify the original object. That's why when we print it out here again, it displays the correct one. But in this case, when we display example, it did not display 14 and 15 because we did not modify example. We're just adding something to it. And then this result is not saved anywhere, right? So that's why it's not appearing here at the bottom. So most of these things are pretty straightforward from their names. Pop here. Okay, so this is where we are currently with our example list. If you say pop, it will remove the last element. It will get 13. And then this is what example will look from. Okay, take note, the pop will give you the return value. All right, so we have this one. Okay, so if I were to say temp dot pop, it should give me the result of 7. See? All right. It will give me the result of 7. Now, if you want to do something with that, then it's up to you. But usually when you pop something out, that means it's not useful anymore. All right. You're essentially removing that from the list. Okay. If you want to read something from the list, then the substitute operator is usually enough. Um, so yeah. In this case, it's popping it from index 0, so it's removing 1. So that's why we're left with 2, 10, 11, and 12. Okay, 13 and 1 is removed. Okay, next, searching in a list using the in operator. All right, so it determines presence or absence, but it does not return the position of the element if found. Okay. So what do we do is we use the method index to locate an element's position in a list. All right. And it raises an error when the target element is not found. So we'll try this one. Okay. So we have a list 34, 45, 67. The target is 45. If target in list, it will print this one out, a list index. So let's try this one. What was I? Okay, so let's say we have 4, 7, and 9. All right. And then we're looking for um what was that again? We're using an in operator to look for a certain target, and then the index will produce an error when the target element is not found. Oh, I mean this one. Okay. All right. So if target, right? If we say target is equals to, let's say our target is 8. If target in temp, right? Then we'll print out the index of that target, right? Else, that target is not found, so it will print out -1. Okay, all right. We'll use -1, the same as an example. Okay. Let's start with something that exists first. So 7. 7 exists in our list, right? So we should see the index number where it's located. Enter what main index is not found. Main index. Ah, right. Sorry. This was a method. Temp dot index. See. All right. And we know that it's index 1. Okay. How about something that doesn't exist? So if we try 8, all right, it doesn't exist. It's going to raise an error. It will print out -1. So this is important. This is why we need an if statement here, because if we did not have this one, what would happen? Okay, if we delete this part, run the code. What's happening? Where is the hmm, for definition? Okay. Oh, all right. So it didn't actually return an error. I expected that it would return an error because the target was never found. Hmm, but I think this is also good practice either way, even though it didn't return an error. If it did not detect anything, that it should return -1. So this is a way for us to prevent errors in our program and then stopping it prematurely. Okay. Usually in data sets, before you actually go into your data set, you actually have a kind of like a sample data set where everything that you need and everything that you don't need is in there. So the program is working on a smaller data set, a practice data set, and then it should work for everything that's in there, right? It should work 100% before actually proceeding to the bigger one where it usually takes a longer time to process. Um, so yeah, there's that method as well. Sorting a list, right? So it's always ordered by position, but you can impose a natural order, for example, an alphabetical order. And then you can just relate these elements by using these comparison operators in describing on how they are to be sorted out. So here we're using the sort method, and it mutates a list by arranging its elements in ascending order. See, in this example, it's changing this one into something like this. So 4, 2, 10, 8, it becomes 2, 4, 8, and 10. Okay, now there's a new word here. We have mutable earlier, right? The word mutable. It means that you can edit, insert, and then remove things from a list. Okay, but this one mutates. It's a verb. It's doing something, right? So the method sort mutates. That means this function will change the original object. Same with what happened earlier with pop. This mutates the original data as well because it changes the original value. See, even append and extend are considered um mutations because it changes the original. All right. Now, why am I specific with this one? It's because in programming we have this kind of rule that when you are editing values that are being passed, right, as arguments or something, you don't usually edit it directly. What you do is make a copy of it and then make edit on the copy. That's the usual practice. So that whenever the need arises that you need the original, you still have access to it. Um it's not edited in any way. All right. So you have to be careful with mutations like this one because you might need the original value later on in your program. So before you proceed into that one, make sure that you actually don't need the original. All right. Uh, Aliasing and side effects. All right. I think we'll stop here after this topic since it's almost 5. And we're about halfway through. And basically, that's because almost everything was discussed before, other than the methods. All right. So that was something new for us. So aliasing and side effects. So this is I don't really see this one commonly happening in other code bases that I see. So this is how it works. You have a list, for example, here, 10, 20, and 30. You are assigning a variable called second to be equal to first. All right. Then first is equals to 10, 20, and 30 if you print it out. Second is also equal to 10, 20, and 30 if you print it out. All right. Now, we are changing the value at index 1 to 99. And this is what it looks like right now, 10, 99, and 30. If you print out the second, it will still be the same, 10, 99, and 30. All right. Because what? Both first and second are just referring to the same location in memory, right? This is what we call an alias, right? The second variable is an alias of the first, okay? Uh, they are referring to the same location in memory. So actually here you're not equating it, more like you're referring to it. You you just letting second here refer to where the first was located, like this one. All right. So this is not how you um copy lists. All right. There are other methods of copying other than this one. All right. So this is what you usually do, right? When you copy things, second is equals to first. And this is what you should be careful with. All right. Um, but are there positive uses of for aliases? There might be. We can think of a situation where there are different departments, and then each department has a different name for the specific thing. Um, let's say, for example, for this department, it's called data A. For this department, it's called data B. But in reality, they're both referring to the same thing. It might be confusing, but what works best for the department, they'll use that one. Um, but there should be someone that organizes all these things and what are the aliases, those kinds of things, and it should be fine in a way. So that's how aliases work. Usually this is a mistake in copying lists. And in order to prevent one, this is what we can do. Of course, we're just gonna copy it, right? So we have a third here. What we're doing is for element in first, we are appending it to the third. So basically you're just getting the value and then appending it on this list, on this blank list. And if first is equal to 10, 99, and 30, after this loop, third is also equal to 10, 99, and 30. Now, if I change index 1 of first, this is equal to 100, right? Now, first becomes then 130. But third still remains the same, all right? Because now, first and third are both different locations in memory. So now they are not aliasing anymore, all right? Other ways of copying. So there are other ways of copying, okay? Let's say, for example, we have temp here, and then we have 1, 2, and 3, a simple list. So if you want to copy something, then you can just say copy 1, for example. You can do something like temp and then a simple colon. Remember the colon operator for substrings, right? You can use that one, a simple colon, and then it will give you automatically a copy of it. See? Exact copies, but they are not aliases. We have another way of copying, and that is for the copy method for list. So for example, if we have this one, right? And then we say temp dot copy, right? Copy one. Nope. We use copy two in this case, just to be sure. Copy two. All right. I guess I'll call this one temp two as well. Yeah. Okay. And then we also have the copy module, but you're gonna have to import that one, so I think it's unnecessary. For now, you can just use this one, or actually there's one more thing. So temp3 is equals to temp3. You can just use the list operator, list of temp3, and this is copy 3, temp3, copy 3, and there you have it. Okay, so now you have three ways of copying a list. Avoid using an equal sign in copying lists, and you should be fine. Okay, let's see. Equivalence. Yeah, I think we'll stop here for now. We'll continue this one next time. So we are at the midpoint of our PowerPoint. That's good. We can finish dictionaries next time and also this other PowerPoint. All right. So I will be uploading the PowerPoints and my notebook on the LMS as well as the recording in YouTube by tomorrow. All right. So do you guys have any questions before we leave? All right. So I think there's none. So yeah, have a great weekend and I'll see you next week. Goodbye.